Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about holes in your hydrodynamic mesh and what that might do to ship motion prediction calculations, how you can fix them, and how important they are. So this is a little bit of a different video. I was going through the process of setting up a hydrodynamic analysis of a variant of the 50-meter generic yacht hull with a bulbous bow, just kind of exploring that functionality. Adding a bulbous bow is pretty straightforward in Orca 3D and in Rhino, and I made it all the way through, importing the mesh, doing the hydrodynamics calculations. You can see everything's looking really good with the radiation and diffraction curves. And then in build ship is just going through the normal course of things, and I plot the results of the ship so far. And here we see a really nice view of the wetted hull in yellow and the dry hull in green here in the ProteusDS ShipMo3D toolset. I noticed like a little bit here, it's kind of black, and I thought that was kind of odd. And normally, sometimes it doesn't show the panel outlines by default. In fact, it doesn't really look like much here. But I thought, oh, well, let's take a closer look at that. What's going on in that little area there? And as I took a closer look, I was like, oh, that kind of looks like a little bit of a hole in the hull. So normally with this kind of potential flow calculation, it's quite tolerant to having little gaps in the mesh for the purposes of what it's doing for wave excitation calculation. I mean, nothing's going to sink or have a drastic change or something like that. But at the same time, you want to minimize any holes that you have. So I thought this would be a good opportunity to show how you can go about fixing something this quickly. How do you detect it? And then also what's the difference when you do fill a hole, and like what kind of changes might you expect to see? And this is just good to highlight, the standard checks you will go through in working with the software, taking a look at it. What do you see? And also just kind of, getting a sense of how much there might be a difference from something like this. So first things first, I go back to Rhino, and this is the mesh that I made in Quad Remesh. This was made in Quad Remesh from Orca 3D hull model, and at first glance everything looks good. Well, it is kind of gray. It's kind of hard to pick out. I do have a red back face on to make sure the normals are facing the wrong way. That's pretty obvious to see. But sure enough, when I look closer at the bow, it's like, whoa, we have a little bit of a hole there. So this is actually really easy to fix quickly. If you're in Rhino and you go to the mesh tools, you can pick this fill mesh button, and then you pick an edge, and it pretty much fixes it right here for you. So we've got two extra little polygons there. What you can do is save this, export as an OBJ, and start the process again. So I've actually done that with a second copy of the project I'm working with here. So if I just reshape this a little bit, I'll put this over here as the one with the hole. And then I've got another one here where we don't have that issue. So this is the one with the hole fixed. So if we just kind of zoom in on that front area there, you can see it's got those extra polygons there. Okay, great. Well, so what might there be some differences there? Well, the first thing is when you look at panel hull and you look at the output, it's going to give you some estimates of things like the mass, that's going to be calculated from the displacement of the hull. You'll see a tiny bit of a difference there. So here you can see these numbers are different. And it's just because of the pressure integral over the wetted hull that it's going through. And the main thing I think that would be, it's not going to be a very big difference because the hole is pretty small. The main thing that I would be kind of concerned about would be like, oh, well, how did the hydrodynamics change dramatically for a hole in the front of the hull? Maybe you might think that surge, radiation, added mass, and damping might be affected. But, when we look at the differences here, I mean, we have sort of 0.0516 added mass, peak added mass in surge. And 0.518, I mean, it's like sort of a pretty small fraction, and that kind of makes sense because the hole is pretty small. But obviously, you do want to be kind of minimizing the amount of holes you have in the mesh, because that's not ideal. I'm gonna make the width of these images a tiny bit bigger just to make them a little bit easier to pick off the peaks here. So we'll go peak here, 0.312 for damping, peak damping and surge. 0.3138, in surge. added mass. So you can also look at some differences in the motion RAO. Checking those, they don't really have that much difference in them as well. So, I think it's one of those things that's an aggregate. It depends on how the face is oriented, which degree of freedom it might affect, and that sort of thing. But mainly, I think this emphasizes it's good to have a workflow where you're sort of look at the mesh visually, do a visual check, make sure things are looking good at various stages in the analysis process. And then, of course, it's not hard to fix. It does mean you're going to have to redo the radiation diffraction calculations. And generally, I think intuitively, like you'd expect, that the bigger the hole, the bigger the change and the bigger the impact it's going to be. All right, well, hopefully that was a useful example to take a look at. Thanks for watching.